Hi, good day, good night, good morning, whatever time it is. Alright. Welcome to another video in the math series that we're doing. It's been a while since I last made a video, but we're back again and we're continuing. Alright. In this video, I want to continue the work that we would have been doing in the in-class session on straight lines, right? So in the very first class, what we did, we discussed 2 points where you're going to find the distance between 2 points, the gradient of the line segment joining 2 points, and the coordinates of the midpoint of the line segment joining 2 points. Alright, so the next step coming out from that is to find the equation of the line segment joining 2 points. But before we do that, I just want to delve into a little talk about what the equation of a line is. Alright? It sounds like something fancy, something big, but all the equation of a straight line is, it is a relationship between the x coordinate and the y coordinate of every single point on the line. So in other words, for a point to be on the line, it must satisfy the particular relationship. So, for example, consider the simplest line that we could think of apart from the x coordinate, the x-axis itself and the y-axis itself. Alright? Consider the line y equal x. Right? That is the line y equal x. That is a line of gradient 1 passing through the origin. Right? We know that 2 points would be the minimum requirement to get a straight line. Right? The shortest distance between 2 points being a straight line. But what we also know is that if we have a line segment or a whole line, it means that we have an infinite number of points that join together to give it a straight line. So, for example, on the line y is equal to x, you have a whole series of points on this line segment here. And every single point on this line segment must satisfy the equation y is equal to x. So in other words, for every point on that line, the x coordinate is equal to the y coordinate. So some of the typical points on this line would be the origin itself, 0, 0, right? We have the point 1, 1, 2, 2, 3, 3, 4, 4, right? So that's the positive side, 0, 0, 1, 1, 2, 2, etc. And on the negative side, you will have something like minus 1, minus 1, minus 2, minus 2, minus 3, minus 3. So we have minus 1, minus 1, minus 2, minus 2, right? Minus 3, minus 3, etc., etc., etc. Alright? So that's the simplest example. And any other example we could think of, the concept is the same. So for example, if we have the line y equal to 2x, which will be a little steeper than y is equal to x, then in this line, every single point, the y coordinate is twice the x coordinate. If we have y is equal to half x, same thing. Every point along that line will satisfy the relationship that the y coordinate is a half of the x coordinate. Alright? And we could have different equations. So if I have the equation, say y is equal to x plus 1, same story. If I have the equation y is equal to minus x minus 1, same story as well. Right? So this is y is equal to minus x minus 1. This is the line y is equal to x plus 1. Alright? So that is all the equation of a straight line is. It is a relationship between the x and the y coordinates of every single point on that line. So in other words, all you need to do to determine whether or not a point lies on a line, if you have the equation of the line, is to substitute the x coordinate and the y coordinate into the equation of the line. And once it works out, then you know that the point lies on the particular line whose equation is given. Alright? That's basically it. That is all it is. So before we get into the mechanics of finding the equation, right? I just did a little talk there to explain the concept, because the concept is important. And you know that wherever possible, I try to give the concept before we get into the calculations. Alright? So following from this video, we will go straight into the mechanics of finding the equation of a particular line segment.